Okay, today's class is our electrostatic potential. Okay, so today's class is
Yes.
electrostatic potential and capacitance. This is again very important chapter from NEET point of view. Okay, so today
Yes.
we are going to discuss with these important topics. Okay, what is electrostatic potential? See, the complete the written over here is what do we understand by this electrostatic potential? It's all about, see, it is electrostatic potential at a point is the amount of work done in bringing a unit positive charge. Yes, what do you want to say something?
No, sir.
Okay. It is electrostatic potential at point is the amount of work done. It is actually a work done. Okay. Suppose there is a charge over here. There is a point, a charge, capital Q. Okay. A charge is kept over here, and you are bringing another charge, small q, from infinity, from very very far away point of to nearby this point. Okay. Then how do we define
Yes.
potential as? Potential is amount of work done in bringing a unit charge from infinity to this point. Okay. This is called the electrostatic potential. This is the basic definition of it. Okay. And potential energy and potential difference.
Yes.
These are two different terms, and both of them play a huge role in understanding the behavior of electric fields. Okay, beta.
Yes, sir.
Electrostatic potential is simply when there is no bringing of charge, only potential due to this plus charge. Then it is defined as V is equal to K times Q by R. Only due to this one charge. Only due to this charge. But when work done is there, when you are bringing this test charge to this source charge. Okay. Here capital Q is the source charge. Okay. And small q is the test charge. Okay, beta.
Yes, sir.
We are bringing this test charge to near source charge, then it is then work has to be done, and here potential is defined as work done is W by Q. And when only due to plus Q charge, then we say electrostatic potential is K Q by R. Okay, this is the basic difference between potential and potential difference. Potential difference includes work done, whereas potential includes only one charge, and that is test charge. Okay, source charge.
Okay.
And unit is defined as 1 volt. Unit of potential is 1 volt, and it is defined as joule per coulomb. That means amount of work done, amount of 1 joule of work done is done in bringing a 1 coulomb of charge. Then it is said is work done is 1 potential is 1 volt. Okay, beta.
Yes, sir.
Okay, good. Let's move ahead. See, checkpoint is what happens when you bring like charges together. Do they repel or attract? Do they repel or attract? This is important. See, like charges means automatically. See, like charge means automatically they will repel. Okay.
Yes. Yes,
Like
sir.
charges when they will automatically repel. Think about how that affects the potential. Just I am giving you a question. Just think how these charges affect the potential. Okay, beta.
Yes, sir.
Okay, let's go to next topic. Electric dipole. What is dipole? What is dipole? See, there are two charges. There is a charge plus q. There is another charge minus q. One charge is known as pole. This is a pole. Okay, this is pole. And when
Yes.
two charges included, then we say dipole. Two poles are included. They are separated by a distance of 2a. Then this system constitutes a dipole. Okay, beta.
Yes, sir.
This system constitutes a dipole. We take the magnitude of charge. This magnitude, not sign. We are taking only magnitude. So dipole is the two equal and opposite charges separated by a distance constitute a system. This whole system constitutes a dipole. Okay, beta.
Yes.
This whole system constitutes a dipole. And the dipole moment is magnitude of charge multiplied by distance between them. It constitutes a dipole moment defined as capital P vector, and it is a vector quantity. Okay,
Yes,
dipole
sir.
moment is a vector quantity because charge is a scalar quantity, but this is vector. Okay, and scalar into vector gives vector. Scalar into vector gives vector. Okay, beta.
Yes, sir.
Okay, nice. So it is a vector quantity. Its unit is coulomb meter. Vector quantity coulomb meter, always along dipole axis. The dipole moment is always along this dipole axis. Okay, beta.
Yes, sir.
Okay, let's move ahead next. Potential due to dipole along the axial. We have studied two different cases, right? In our junior classes, potential due to dipole in
Yes.
axial position and equatorial. We'll discuss first with axial position. On the straight line is the axial case. Means there are two charges, and we are here finding potential due to this dipole due to these two charges. Suppose there is see, you can see the minus q charge is kept over here, plus q charge is kept over here, separated by a distance 2a. Okay, so this system constitutes a dipole. Now we have to find potential due to this dipole at a distance r. Here, this is the distance r. Okay, at a certain point P along the dipole axis. This is the axis. So there is a definition. We have to find see, due to this dipole, V is equal to this due to plus Q. V is equal to, we know. Okay. So there is a derivation. We have to study and let's discuss, go through. Just go through this definition. Okay, this is the standard formula. And P is nothing but Q into 2A by R square. Okay, beta. Here we are assuming, suppose a point X from certain point P. Okay, so we have to take distance and we are solving. V is equal to K Q upon X plus R, and this is due to plus Q. This is plus Q and plus K due to minus Q is X minus R. Okay, beta. Once you solve this equation completely, what you will get after solving is this. Okay, as neglecting X is bigger than R. This you have to take assumption. Okay, and then when you solve this completely, we'll get this 2P upon R square. Okay, beta. Take the LCM and then we
Yes,
solve,
sir.
you get this value. So the important point to be noted is potential is not equal to 0 here. Same direction as dipole moment. The potential of this dipole is along the dipole moment P. So V is also dipole moment, same direction. Okay, both the directions are same. Okay.
Yes.
Oh, the example. Remember, see this P actually this if you take here, see the formula is actually V is equal to 1 upon 4 pi epsilon naught in terms of theta P cos theta upon R square. Okay, this is the actual formula. If theta is along the axis, then theta is 0. Okay,
Yes.
along the axis theta is 0 and cos 0 is 1. Therefore, we have written this formula. This cos 0 is 1. V is going to P by 4 pi epsilon naught 0. If we take theta is 90, then it becomes equatorial. Theta is 90, then V is 0. This is the case of equatorial. Okay, we'll study in the next topic. So potential is maximum along the axis in this case. Okay,
Yes, sir.
so this is the actually derivation. We have to see this. Point A over is kept over here. Point A, point B, point O. This is to A, and we are finding somewhere over here P. This say X. This is distance R, and we are finding somewhere here over here. Okay, X. This is complete derivation. If you want to do this, you can do it by your own. V plus D2 plus charge K Q upon this is minus Q. This is plus Q. So X minus R, X plus R. V at A. V at A is X plus A. This you take this as center point. So this is X plus A. Similarly, V at B. K minus Q upon X minus A. Okay, take LCM. Net V net VA plus VB. K Q upon take LCM. K Q take K Q outside. 1 upon X plus A minus 1 upon X minus A. This will get what we get is V is equal to 1 finally 1 by epsilon naught Q into 2A upon R square. This whole ball becomes P. Okay. Okay, beta.
Yes.
Okay, these are basic derivation. Small derivation I have done. You have to do it completely by of your own. Try to do it by your own. Okay. Now potential due to dipole at equatorial position. Okay.
Yes.
Okay. Equatorial position in the sense point is kept something somewhere over. See, this is minus Q at point A. This is point P plus Q. This it is separated by a distance 2A. Okay, beta. And somewhere we have to find O at O
Yes.
or P. Say P. It is at a distance of R from A, and similarly R from B. R, and from here it is perpendicular distance drop a perpendicular. Then if you find this is R, this is 2A, this is A. So this is R square, this is R distance. We are finding at R. So square root of X square plus A square. Okay, similarly this is also X square plus A square. This point it is this point O. Okay, beta.
Yes.
Okay, just you can simply find it. B is equal to B at A K Q upon distance perpendicular square root of X square plus A square. Similarly, if we have to find BB is equal to K minus Q upon square root of X square minus A square. If you find finally B net after solving completely is equal to BA plus BB, we will get 0. Okay. So what we understand from this is how we have got B is equal to 0. I have explained once. Okay. How we have got B is 0? Yeah, because at equatorial position, simply we can find from previous equation also 1 by 4 pi epsilon naught P cos
Yes, sir.
theta upon R square. Take theta is equal to 90-degree perpendicular distance, so V is equal to 0. Okay, beta? So potential is
Yes.
there, but it is cancelling out. Therefore, V is 0. V is 0, that doesn't mean there is no potential. Potential is there, but effect is nullifying. It is nullifying effect. Okay? So
Yes, sir.
field exists. See, field exists, but potential is 0. Most asked concept in NEET. Remember. Okay? Now, we have a small comparison. How electric field versus potential. Electric field versus potential is position at axial position. It is at axial at equatorial. At axial it is non-zero. Potential is non-zero because it has some value. What is the value we have recently calculated? V is equal to 1 upon 4 pi epsilon naught P cos theta upon r square. Okay. Whereas for equatorial position, V is 0 potential. Okay. For electric field, it is
Yes, sir.
from. For electric field, E is equal to 1 upon 4 pi epsilon naught 2p cos theta upon r cube. Okay. And here also non-zero. Actually, formula is uh, E is equal to 1 upon 4 pi epsilon naught P cos theta upon r cube and bracket. Sorry, P 2p upon r cube. P upon r cube. Sorry, P upon r cube. It is only P upon r cube and in bracket it comes over here as 2 cos theta I cap plus sin theta j cap. Okay. This is a complete derivation for electric field. We have not done, but actually it comes as it is. 1 by 4 epsilon naught P upon r cube 2 cos theta I cap plus sin theta j cap. So it's not visible. So this is the basic comparison how electric field and potential varies. Okay. Now force on dipole. See, as you can see from here, these are electric field lines. Electric field lines in this direction. E charges are kept. Okay, the charges are kept. It is plus q charge. It is minus q charge. Force on this charge in this direction plus qe. Force on this charge in this direction minus qe. So net force net in uniform electric field is plus qe minus qe. Force is 0. Okay, beta. This is how 0 comes. Because in uniform electric field, plus qe this direction minus qe this direction, net force is 0. Okay, beta.
Yes, sir.
Only rotation or torque exists. Force is 0, torque is not 0. Non-uniform electric field, net force is not 0 because E is not constant. Okay, E is not constant.
Yes,
Therefore,
sir.
F is equal to QE E some value and F is equal to minus QE E some value, not 0. Okay, so net force is not 0.
Yes.
So dipole moves. Motion happens only in non-uniform field. Okay, this you should understand and note that. Okay, beta.
Yes, sir.
Okay, next torque on dipole. Torque on dipole is rotation begins. So how do we find torque? Torque is nothing but formula is C. Any dipole moment. See this P. This is P means plus Q minus Q and in with E forms P is perpendicular to electric field. This forms torque. Okay, torque is P vector cross E vector. Okay, so
Yes,
this
sir.
the cross product forms sin theta. Cross product sin theta is equal to sin theta and dot product is equal to cos theta. Okay, beta. Concept is try to
Yes, sir.
align dipole with field. Special case exists when theta is equal to 0, torque is 0, theta is equal to 90 degree, maximum torque. Okay, beta? Because
Yes.
theta is 0 means sin 0, it is 0. Theta is 90 degree means sin 90, it is 1. Okay?
Yes, sir.
So here we have to understand this. That's why it is given. Now, potential energy of dipole. Similarly, simple formula is we have to understand how this comes. See how it comes is u is equal to minus of integration tau d theta. This is the basic methodology. How we get this? Okay, beta.
Yes, sir.
So u is equal to minus of tau d theta. U is equal to minus of integration tau is p e d theta. Okay, p e d theta or p e cos theta d theta. Okay, this is how
Yes, sir.
we get the values of e. So u is equal to minus p e cos theta. Key points is minimum energy stable aligned. Okay, maximum energy unstable.
Yes, sir.
So we have to understand how we get this P energy. Tau d theta. Tau is P cross E. Sorry, this P cross E. Okay, and we get not integration P. We get P sin theta. P cross P E sin theta d theta. And after integration we get P E constant. Integration of sin is minus cos. Okay.
Yes.
Yeah, this is what you get. This is what you get. This is how you get. You get, okay. U is equal to minus P sin theta. Okay. So stable when dipole parallel to field, because cos theta, then only cos theta is 1, because parallel to field means theta is equal to 0 degree. Okay, beta.
Yes, sir.
Great. So this is how you get potential energy. Fast revision checklist. Dipole moment direction always negative to positive. Dipole moment is always negative to positive. Okay, beta.
Yes, sir.
Axial V is not equal to 0. Equatorial V is equal to 0. Torque is P sin theta. Tau is equal to P cross E. Okay. Energy is minus P cos theta. Uniform field, no force Q, because QE and minus QE is equal to 0. Okay. So non-uniform fields, it is not 0. Force exists. Work is path independent. Work is always path independent. Okay. Okay, beta.
Yes, sir.
Now, moving ahead, capacitance. Understanding the basics. What is capacitance? Capacitance is the ability of a system of to store charge per unit voltage. Okay, it stores. It is nothing but actually storage energy. Energy storage. It is a parallel plate capacitor. It is used to store energy. Store electrical energy. Okay, the
Yes,
stores
sir.
electrical energy written over here in an electric field. So when you to provide energy, it charges. When you provide energy, it charges. When energy is not supplied, it discharges. So charging and discharging. It is a cyclic process. It goes on. Okay. Capacitance is defined
Yes,
as
sir.
charge per volt. It is volt and its unit is farad. The 1 farad is defined as 1 coulomb of charge is used to store 1 volt of potential. Then we say this energy stored is 1 farad. Okay, beta?
Yes, sir.
1 farad. Unit is 1 farad. So you should remember this basic definition. Okay. There are different types of
Yes.
capacitors, but we are focused only on one capacitor, and that is parallel plate capacitor. Parallel plate capacitor. Parallel plate capacitor is capacitors are made of two parallel plates. Parallel plates. Both the plates are charged. It is plus charge over here and minus charge over here. Okay, beta.
Yes, sir.
Now formula for parallel plate capacitor. See, it is we have to derive. We are not going to derivation. We are not going to derivation, but remember epsilon naught A by D. And derivation is simple. We know C is equal to Q upon B. B is ED, and okay,
Yes.
and so remember this formula. C is equal to epsilon naught A upon D. That means capacitor depends on area of cross section of these plates and distance between the plates. Area of cross section. Okay, beta.
Yes, sir.
Energy stored in capacitor. Energy stored in capacitor is work done to charge it. So how much amount of work is done to store the capacitor is its energy, and it is denoted as half C V square. And energy stored is directly proportional to square of energy is directly proportional to capacitance, and energy is directly proportional to square of the voltage supplied. Okay, how much voltage you supply across capacitor? This is capacitor, and this is voltage V. It is capacitance C. So energy is half C V square. Okay, beta.
Yes, sir.
So energy stored in capacitor is defined as this. Dielectrics and capacitor. We should note this. See, there is a parallel plate capacitor and there is small dielectric slab of thickness T is placed inside it. Okay, this is a parallel plate capacitor. U is so we find how do you find when dielectric place C is equal to epsilon naught A upon D minus T plus T upon K. Okay, okay, beta.
Yes, sir.
Where D is the thickness of these plates, T is the thickness of this dielectric, and K is the dielectric constant. Okay, beta.
Yes, sir.
Okay,
Yes, sir.
nice. Now, simple concept says dielectric constant K increases capacitance by a factor of K. increased by factor of T. If K is inserted in the capacitor, then dielectric constant increases the capacitance. C is equal to K C naught. Okay, beta. Now, formula quick revision. What we have studied till now. Electrostatic potential V is equal to K Q upon R. This you should remember. Capacitance of parallel plate capacitor C is equal to epsilon naught A upon D, and U is equal to half C V square. And finally, capacitance with dielectric constant K C increases or multiplies by K into C naught, where C naught is the original capacitance. Okay, beta. Just memorize this formula. So your formula should be on your tips. Formula on tips. Okay.
Yes, sir.
Just try to solve these questions. Two charges Q1 and Q2 are placed 20 centimeter apart. Plus Q minus Q 20 centimeter apart. Point A, point B. Okay. Calculate
Yes,
the
sir.
electrostatic force between them. How do you calculate the force? How do you calculate force? Sridhar, what is the formula? Rita,
Yes, sir.
what is the formula for calculating electrostatic force? Yesterday we studied, na?
Yes.
Can you recall it? Just
F is
go
equals
through the
to
lesson.
F is equals to K Q1 Q2 by R square.
Yes, that's what I was asking for. K Q1 Q2 upon R square. Okay. What is Q1 3 microcoulomb? Okay. Just put the value and find the answer.
Yes, sir.
Just put standard values. Okay.
Yes, sir.
You have to convert microcoulomb to coulomb. Coulomb. Here also coulomb. This is centimeter to meter. Okay, beta.
Yes.
Just find the values. Put the value and find the answer. K value of K is 9 into 10 raised to power 9. 3 into 10 raised to power minus 6 into 5 into 10 raised to power minus 6 whole divided by 0.2 square. Is that calculate the answer, please?
Yes, sir.
Okay, Rita?
Yes, yes.
Let's try to solve this question completely. See, let me simplify. You can take this the separate values 9 into 3 into 5 and 0.2 square is 0.04. Okay,
Sir, 3.3.
very good, very good. You got the answer, right?
Yes, sir.
Shabash. F is equal to 3.3 Newton. Very good. Shabash. See, solve this one. Solve this question. C is given here
Yes.
and the distance between plates D is given 1 mm. And what will be the new capacitance C dash if the distance is reduced to 0.5 mm? New distance D dash C dash is going to ask new mm, new distance is given 0.5 mm. In this case, calculate c dash. Okay, we know c is equal to epsilon naught
Yes.
a by d. C dash is equal to kc. So see, simply you can apply. C is inversely proportional to D. Okay, so C1 is
Yes, sir.
inversely proportional to D1, or C1 upon C2 is equal to D2 upon D1. Okay, you can see C1 is given,
Yes,
D1
sir.
is given, D2 is given. You have to find C2. Okay,
Yes, sir.
find C2 from here. C2 is C1 D1 upon D2. So find C2 from here.
So we should convert the millimeter also to meter, right?
Sorry.
The millimeter D2.
See that? What you said?
The second distance, the new distance, it is given millimeter, right? You have to convert to meter.
No, both are in mm. No need. Both are same distance units, so no need to convert.
0.4 into 10 raised to minus 5.
0. Point.
4.
See, let me see. C1 is 2 microfarad. D1 is 1. 2 into 1 upon D2 is 0.5. Means 1 by 2. So you can see, it simply becomes 4 times. Okay. The new capacitance will be 4 times of old C. Okay. Okay, Beta?
Okay.
This is a simple question. Okay. It's okay. Solve third one. Next question. It's okay. What is the energy stored in the capacitor of capacitance 10 microfarad when connected to a 200 volt battery? C is given 10 microfarad, 10 into 10 raised to power minus 6 volt. V is given 200 volt. You have to find energy stored. U. We know energy formula. U is equal to half CV square, which implies U is equal to half into 10 into 10 raised to power minus 6 into 200 square. Just calculate this value and tell me the answer. Okay?
Yes, sir.
Just find the values, find the answer.
Mm, 0.2.
Sorry.
0.2.
8. Let me check.
No, 0.2.
0.2. Okay, let's see.
Yes.
It is 5. 5. This is 2 into 4 into. That means it is 5 into 10 raised to power minus 6 into 4 into 10 raised to power 4. It is 5 for 20 into 10 raised to power minus 2, and it is 0.2. Shabash. Correct. Okay, beta. So this was just a basic
Yes, sir.
small questions. Now, important tips for NEET success. You should focus on this. Okay, beta. Focus on concepts.
Yes, sir.
Focus on concepts. Never just memorize formulae. Understand how they are derived. Okay. We have studied in today's class 2 derivations for dipole, for axial, and dipole for equatorial. Understand the derivations for both. Okay, beta. Not just that, for torque, for
Yes, sir.
energy, for force, torque, energy. All derivations you should know this. Solve a variety of problems, including PYQs, practice makes perfect. Okay, so start just with PYQs, which not don't just start PYQs. Start with your basic textbook questions. Okay, whatever you're studying, I hope it is NCRT only. solve examples and then unsolved examples and then go for PYQs. Okay,
Yes.
use diagrams to better understand how charges interact or how electric fields behave. Okay, time management. Don't spend too long on one question in the exam. Keep an eye on the clock also. Suppose just start with easy questions first, or the questions which are easily going on. Start with so it builds confidence. Okay, easy question if you are able to solve questions, it
Yes,
will
sir.
give you confidence, and with that confidence you can go ahead. Okay, beta.
Yes.
Okay, nice. So these are the important topics we have to discuss. We had done. So we have to understand this. Okay.
Yes, sir.
So what we have started with this is we have started with electrostatic potential and capacitance. And so today's topic was, let me summarize once again what we have done till now. Potential is electrostatic potential at a point is the amount of work done in bringing a unit positive charge from infinity to that point. Potential energy and potential difference play a huge role in understanding the behavior of electric fields. Okay. Electrostatic potential is nothing but the amount it is bringing a charge from infinity to a particular point. It is that charge is a test charge, and we are bringing the charge to source charge. So two different electric dipole. Okay, what this is what we have to do.
Yes, sir.
Direction is from negative to positive. Dipole direction is always negative to positive. If dipole is this is the direction, you should know this. Okay, Buddha?
Yes, sir.
You should know the direction. This. Okay? Know this direction.
Yes.
Need check point, vector quantity. This is vector quantity, coulomb meter, and always along dipole axis. This is you should remember always along dipole axis. Okay? Potential due
Yes,
to
sir.
dipole, axial position, equatorial position. This is along axial axis position. Just go through this diagram once, go to understand how it has come. Okay, now we move ahead for this further. Once you are done with this, this is
Yes,
the
sir.
basic difference between electric field and electric potential. Okay? There is also one derivation one for electric field. Just note down this both the derivations for electric field as well as potential. Okay? Derivation for both are important.
Yes, sir.
Okay. So force on dipole is this. Now torque on dipole is this. Rotation begins. Just go through this slide once. Potential energy of dipole. This is the energy stored due to rotation of dipole. Okay. This is the fast resonance checklist. Okay, beta.
Okay, sir.
Okay, nice. This is the capacitance. Understanding the basics. Parallel plate capacitor. Energy stored in the capacitor. Dielectrics and capacitors. A dielectric is a insulating material. Actually, dielectric is an insulating. You should know this, right? It is not conducting material, but in certain circumstances, it conducts electricity. Okay, when kept in an electric field. This is the formula conclusion for potential K Q upon R. Electric field capacitance of parallel capacitor C is equal to epsilon naught A by D. Okay, we should note once again. It is only due to Q, but not due to dipole. For potential due to dipole is potential due to dipole V is equal to K P upon R square. Where P is the dipole. Okay.
Yes, sir.
Similarly, electric field due to dipole is E is equal to 2 K P upon R cube. Okay, these are basic knowledge you should have. Okay. Now, energy stored, capacitance with dielectric. And now we have done three questions in PYQs. First question, this is the second question, and this is the third question. We have done three questions, and then finally, important tips for NEET success. Okay, beta? Okay.
Yes.
So we'll wind up today's class. Okay, beta?
Yes, sir.
Okay. Okay, beta, bye.
Okay, sir. Thank you, sir.
Okay.